Welcome student to this video where we will discuss some proofs in the pre and image of a function. If you haven't seen the previous video, I highly recommend you see the previous video to get understand of the results that we used in image and pre-image of a function over a set. In this theorem here in front of us on the screen, we need to prove that f inverse of d, which is d of course is a subset of b, is gonna to be subset of D with equality that will hold if f is surjective. So in this question, we need to prove two things. First, we need to prove this statement, and then we need to prove that the equality holds if f is surjective. So let's start with the first one, and we want to prove that one set is subset of the other. We have a set on the left. We want to show it is subset of the right. So we will use pick a point method. So I will take a point here and I will show that it is here. So number one, we will use pick a point method. So let y in this set f of, let me keep using the same color green here so that I think it will be important we keep using this color here just not to confuse ourselves. This means y equal f of x for some x belongs to the screen set. Some x belongs to f inverse of d. That's the first definition of y as in something in green. Now, what can this tell me more? Let's try to see what we can say more. This will equal f of x for some. Now, what this is telling me? This one is telling me, if I translate it directly, it means for some x, comma. Now, if I translate only this one here, this is telling me that f of x, whatever is f of x, belongs to d. That's what it means. Now, let's see the situation. F of x is already named y. So, in this case, I can directly jump into the fact that y belongs to d from here. And that's exactly what I want to prove. Yes, that's exactly what we want to prove. So it is only just moving the question forward, writing the definition in the right way, analyze it, move from one direction to the other, and that's what we get. Now, for the equality, to show the equality, we assume f is surjective. This is the first fact that we need to keep in mind. And we take something in D, and we want to show as this one is in the f of f inverse of d. We want to show this one. Let me put a question mark. This is where we can say the equality. Remember, if we have equality, we have to show that the left subset from the right is subset of the left. And that's exactly what I want to show. I will take something on the right and I will show it is exactly left in the left. So let's start with y in d. We write since y belongs to d and f is surjective, and that's the important piece of information. If we have surjective and I have some y here, what can we get? This is a, this is b. What can we get? Of course, because it's surjective, it means there must be an x here where x related to y. So there exists x in A such that y equal f of x. That's what we get. Now, is that what we want to prove? No, remember, we want to prove that y is in this set here. So we need to prove that the other direction hold. So we start with y in D. Okay, that's fine. We write it as y equal f of x for some x. The only missing is this correct or not? Of course, this is correct because this is the same as saying y equal f of x for some x, not just in A. I know that x will be in f inverse of D. Why this is true? Remember, because y equal f of x and this is in D. So here y will definitely be f inverse of D. And that will prove the first part. Now for the as of the second part, remember for the second part we want to show that any set, let me just call it C, just not to confuse ourselves. C is subset of f inverse of f of C. So again, let x in C. Now, what happened? What we have here? I have a set called C. This is C. And inside it, I have an x. Now, can you tell me what can we get here in y? We will get a y such that x related to the y. So let y equal f of x. Of course, what information we have about y? Because it's equal f of x, this y must live in f of c. That's the information that we have. And since y equal f of x, definitely x is in f inverse of f of c. Remember, x is in f inverse, it means f of x belongs to the set, and that's exactly what we prove here. So that's exactly the proof that we have here. Last but not least is if we ask ourselves what happened to the complement. And let me just quickly here do part one by one. So we have the proof, and this is part number one, which is, again, I will take something in this set and I hope to show it is in this set. So let x in f inverse of the complement. This means f of x belongs to the complement, which means f of x does not actually belong to D. And that's exactly the meaning that we have it from here. So if f of x is not in D, that's definitely x is not in the complement. Of course, the second one, I would like you to think about it by yourself, but this is exactly what we get here. Of course, if you want me to continue this one, this means x does not belong to f of D, which means x belongs to the complement. And all those statements are f and only f. Please write for me the comment what should be the answer for part 2. Thank you for watching this video.